Welcome back to Well, That's Interesting, the looking at either ends of these creatures edition. Today is episode 257, how thumbnails helped rodents spread all over the world, and these queen ants produce two different species, an absolute first. My friends, today, what could I say about today's show? Although I've researched and written for this podcast, going on over 5 years now, I can safely say that week after week, nature always leaves me astonished. When it comes to how things work in the world around us, let's just say there isn't only one way or two ways to make it work. The only thing about nature that's consistent is that it will take a creative route to keep going. She doesn't color in the lines. Case in point, in the first half of the show, thumbs. Off the top of your highly evolved head, how many creatures do you know that have them? Now, we can go easy on ourselves because the exact count is difficult. And it's difficult because there's a wide range in the opposability and function of these digits across different species. Having an opposable thumb means you can bend and flex that baby so damn far you can touch the tip of your thumb to the tips of each of your fingers, like the great apes, lemurs, and some surprising colleagues on this list, such as koalas, the waxy monkey tree frog, possums, chameleons, the slow loris, which is a primate that looks like you took the lint from a dryer filter, dyed it white, and stuck adorable big eyes on it. They have opposable thumbs, and although the urge to squeeze them is high, please don't, they're the only venomous primate. Squeeze a panda instead, who have opposable thumbs, and most fucking birds. Now, not everyone with a thumb can be just as dexterous, though. Some animals have adaptations that function similarly to thumbs, but they're not considered, air quotes, true thumbs. But that doesn't stop them. In this case, I'm talking about rodents. In the squeaky study we'll be diving into, researchers surveyed over 400 different genus of rodents, and wouldn't you know it, 86% had thumbs, bro. And most importantly, a coveted thumbnail. Those researchers believe it's that feature which explains, quote, how rodents evolved into so many different species that thrive all over the world, end quote, from their press release. We will look at the paws of some of these creatures and get a little freaked out about how similar they are to ours. We are going to talk about why nails are so damn important and how they're different from claws. We will meet the team that's hot for rodents and dive into their study. A study that reveals how a detail as tiny as a thumbnail can foster success. Then after the break, a plot that sounds like it came right out of some pulpy science fiction paperback. A six-legged queen who mates with a male of another species and then clones him. Of course, it's reality, and that queen belongs to the Iberian harvester ant. Now, if you said to yourself, off the top of my highly evolved head, I can't think of any other animal that can willfully pump out a completely different species. Yeah, you're right. This is the only creature known so far who can do this, and it's enough to send shockwaves through the science community. Quote, it's almost impossible to believe, and it pushes our understanding of evolutionary biology, end quote, said Michael Goodisman, an evolutionary biologist at the Georgia Institute of Technology who was not involved in the new research we are about to get into. Michael went on to say, quote, just when you think you've seen it all, social insects reveal another surprise, end quote. That was from an interview with Science Magazine, and you're going to need to buckle up. We will meet the Iberian harvester ants and the team that discovered their queens lay eggs with different species in them. We will get into the mind-bending way she can do this and the mind-bending reason as to why she does this. Let's just say she puts all other dominatrixes to shame. It is wild. Oh, and hi, I'm Jill Chacha. And if this is your first time listening, welcome to the flock, my equally mind-bending business goose. To begin, I'm going to need you to get the fuck outside and touch some grass. So please, if you will, get as low to the ground as possible. or if you prefer, as high up in the nearest tree as your soft limbs can carry you. Unless you're in Antarctica, there is a very high probability we're going to find some small, dark, pellet-like droppings within a few feet. And I can see your face from here. Your look says, Jill, you're talking about poop, aren't you? We just started, and we're looking for poop. Why are you doing this to me? Well, great questions, and thanks for playing. The point of this was to emphasize the following statistics. Rodents make up about 40% of all known mammals. Yeah, 40% of all known mammals. There's over 2,500 species, which means when I say the word rodent and the image of a mouse or a rat comes to mind, please know that these babies come in all shapes and sizes. Woodchucks, beavers, porcupines, prairie dogs, capybaras, and pocket gophers are a mere handful of cuties that belong to this extensive family. Other pointy, gnawing friends who you think would be on this list, like raccoons and rabbits, well, they're not rodents. As so wonderfully explained by James Ashworth of London's Natural History Museum, quote, "The key features which set rodents apart from other mammals are found in their mouth. They have a single pair of incisor teeth in the upper and lower jaws, no canines, and a broad space between the incisors and cheek teeth. This specialization allows their incisors to gnaw through the tough parts of foods, such as the outer husks of nuts, while the molars grind down on the edible contents." End quote. Well, the rodent skull is basically a fucking drill. And it's a drill that seems almost impossible to stop. These incisors grow continuously throughout their lives, and this perpetual growth compensates for the constant wear from chewing on hard materials. And this sounds like a lot already, but hold the fuck on. These incisors are self-sharpening. Yeah, the front surface is coated with hard enamel, while the back is softer dentine. As our friends gnaw, the softer dentine wears away faster, creating a razor-sharp beveled edge for cutting through wood, seeds, or the walls in your home. If you happen to make eye contact with one while you're on the john, you'll probably notice these teeth have a shade of orange. And if that's unusual to you, you're fucking right. That color is due to the presence of iron in their enamel. So, yeah, they have iron in their teeth. Combine this with their rapid reproduction rate and a highly flexible, non-fixed rib cage that can compress and change shape, allowing them through imperceptible small spaces. It's no damn wonder they're seemingly everywhere. In fact, the only other mammal you'll find to be just as rampant as rodents is us humans. So their bones and teeth are quite an arsenal. But what if I told you, maybe, just maybe, one of the overlooked keys to their success, what helped them open the door to their ascension to the mammalian throne, was a thumbnail? Please, drop whatever nut you're holding right now and pick up your phone, head on over to today's post and brace yourself for something that may leave you a smidge uncomfortable. I'll give you a second. Yeah, I know. There's really nothing I can do or say to actually prepare someone for this, but that is a close-up of the right paw of a kangaroo rat. And as you can see, it has 4 fingers, each topped off with a long, sharp claw. But there's an additional finger here, and it's a goddamn thumb. And on that goddamn thumb is a broad, flat thumbnail that's a bit too familiar. Now, if you're taken aback, you're not alone. Quote, "When I talk with people about this research, I always start by asking, did you know rodents have thumbnails? Most people don't. I didn't. I had studied rodents for years, and I didn't know anything about their nails until I started working on this project at the Field Museum." End quote, said Field Museum of Chicago's research associate Rafaela Misagia. Nailed it. An assistant professor at the University of Sao Paulo in Brazil and co-author of the study we are nibbling on right now. Rafaela said this in a September news release. So yes, even hot for rodents, Rafaela was blissfully unaware of their paws until, quote, this project. So, what the fuck is that? let's get into it. Enter Northwestern University neuroscientist Gordon Shepherd, who had his personal rodent thumbnail awakening prior to Rafaela. And it took such an obsessive toll on his mind, he went down a rabbit hole, or rather a rodent hole of sorts, leading to the realization that some had nails, but some had claws, and, wait for it, some had no thumbs at all. As to how many had which and why, that's been never looked into. Can you believe it? To find a pattern, Gordon turned to the Field Museum in Chicago, which, fun fact, is home to one of the world's largest collections of mammals. So you could be damn sure that if any crew would be on board for counting and categorizing rodent paws, it would be the one here. Together with Paula Jenkins and Anderson Fayawa, nailed it, two curators of the museum and study co-authors, they had what I can only assume was the greatest time of their lives, poking and prodding samples from 433 genus groups across the rodent family. And if that number sounds like a lot, it really is. There are over 530 genus of rodents, and this crew for the ages reviewed samples, cross-referenced with photos and scientific literature of 433 of them. There's actually a photo of the team giving one collection of giant rats a look over. That's over at our socials for your enjoyment if you'd like to take a look. Anyway, after all the paws and claws and nails and thumbs were counted, what did the team find? Drumroll, please. Thank you in the back. Of the hundreds of genera they surveyed, a whopping 86% included species with thumbnails. Massive number, and it's shocking as fuck. But it's not as crazy as the extensive family tree that the team was able to craft from the amount of information at their own fingertips. For you see, the field's collection also includes extinct rodents. This allowed the gang to time travel, all while tracing back just how far thumbnails could be found. Quote, some of the earliest known rodents, dating back to about 50 million years ago, have thumb bones that are short and wide, a shape more consistent with bearing nails rather than claws, since nails tend to be broader, while claws tend to be typically narrow and curved, end quote, said Anderson Fayawa in an interview with Laura Basis of Popular Science. My hairless business goose. The ancient thumbnail may help explain how rodents conquered all but one continent. Let's talk about nails for just 1 minute. Only one other group on Earth evolved nails, and I'll give you one guess as to who they are. That's right, primates, which, after millions of years, included us humans. Our ancient ancestors, were the grabby climbing type. But to do so with exceptional accuracy and strength, fingers needed to broaden at their tips. As their fingers flattened out, so did the claws, eventually forming into the thin scales of double-layered keratin that we inherited today. Without them, the soft tissue of the fingertips would lack a rigid structure to press against when gripping an object. And get this, the oldest fossil evidence of nails appearing on ancient primates dates back 55 to 56 million years ago, about when the earliest known rodents were evolving theirs. At the time, 50 million years ago, during what's called the early Eocene era, our Earth was a warm, largely ice-free hothouse, so much so that the Arctic supported lush green forests. So it looks as though we were not the only ones who thought getting a grip is a great way to adapt to and spread your species around this world, now popping off with new flora. Anderson and the gang tested if there was a correlation between rodents with nails being likelier to live above ground, while fossorial rodents, or the ones that dig, were more likely to have claws on their thumbs. And they found exactly that. Difficult food sources, like nuts, are a high-energy resource whose outer casing can leave one completely empty-handed. No pun intended. Even with a drill for a face, it's pretty useless if you can't hold that nut securely in place as you go to town. To even reach these sweet nut options, you have to climb up trees and travel over branches to find them. Hell, you might even have to cover a continent. In an interview with Science News, in the not-too-distant future, Anderson plans on using high-speed cameras to continue the investigation on short thumbnails and rodent dexterity. So, plan on me forcing some precious nut-handling videos on you shortly. You know what I mean. After the break, we're moving on from thumbs to eggs, and what's inside them has completely shattered the laws of reproduction. After this, you might just say there are no laws. So please, stay tuned.
Does it ever feel like you're a marketing professional just
speaking into the void?
But with LinkedIn ads, you can know you're reaching the right decision makers, a network of 130 million of them, in fact. You can even target buyers by job title, industry, company, seniority, skills, and did I say job title? See how you can avoid the void and reach the right buyers with LinkedIn ads. Spend $250 on your first campaign and get a free $250 credit for the next one. Get started at linkedin.com/campaign. Terms and conditions apply.
This episode is brought to you by Nespresso. Gift magical mornings with Nespresso Virtuo Pop. Compact and stylish, Virtuo Pop is made to meet every morning coffee craving. From espresso to coffee, hot or iced, at the click of a button. And celebrate the season with Nespresso's limited edition coffee flavors. Sweet almond and hibiscus, cinnamon and candied tamarind, and festive double espresso. Magic in the making. Shop the holiday gift collection exclusively at Nespresso.com.
And we're back. We are so back. And my friends, this portion of the show is going to have so many jaw-dropping moments, I recommend just staying outside and low to the ground. Let's start off with this banger to help set us up. It's the first goddamn sentence of the study we're covering right now. Quote, living organisms are assumed to produce same species offspring. End quote. Yeah. I would say yes, the production of same species offspring is so expected we don't even stop to think about this concept. If, for example, a chicken lays an egg, I don't think our first reaction is putting our hands on our hips mumbling, I wonder what's going to hatch out of that. Well, that first sentence, like I said, is setting us up for a shocker. When it comes to the Iberian harvester ant and their queens and her eggs, you're going to have options to choose from. Let's get into it. And to do so, may I introduce you to the perfect person to conduct this study. One so revealingly titled, One Mother for Two Species via Obligate Cross-Species Cloning in Ants, co-author, and evolutionary biologist Jonathan Romillet of the University of Montpellier. I nailed it. Located on the East Coast. Sorry, I know. I got too confident. Located on the coast of southern France. And as reported by Eric Stockstad of Science magazine, Jonathan grew up in a rural village in France and would pass hours at a time watching these ants, quote, hypnotized by their synchronized movements, end quote. As the years passed and Jonathan became a university student, his je ne sais quoi for harvester ants didn't dampen at all. He kept them as pets, a choice I assume that made him extremely popular on campus. After earning a degree, Jonathan could finally transition his feelings for these creatures into tangible studies for the world, allowing us to see what could possibly be so special about them. Turns out, these unassuming reddish-brown ants with relatively small eyes, covered in a kind of peach fuzz, are way more extraordinary than anyone, including Jonathan, could imagine. Back in a year I could no longer recall, 2017, Jonathan and his colleagues were doing what you'd expect them to be doing. Sequencing the DNA of female Messer ibicorus worker ants, aka the thousands upon thousands of sterile sisters who run the colony. Some forage, while others tend to the eggs and larvae. There are waste removers and guards. Some wait hand and 6 feet on the queen herself. As Jonathan put it in an interview with Eric Stockstad, quote, it's like a little city, a little society, end quote. It was this run-of-the-mill DNA test that kicked off what would turn out to be one hell of a larger discovery. After looking at the Maury Povich-esque results, the DNA revealed that the sisters are a hybrid. The father belonged to a member of the same genus Messer, but the species was different, Structor. Now, hybrids between species are nothing new. Mules, for example, come from donkeys and horses. Ligers are a cross between a male lion, and a female tiger. And these two ants' nuclear DNA suggests that they shared a common ancestor, the last common ancestor, some 5 million years ago. And even though that's a bit of time, it's still close enough where M. ubiquitous and M. structor can produce offspring. But here's the thing. The team were testing ubiquitous workers from colonies where the closest M. structor colonies were more than 700 kilometers away, or rather 434 miles away. Let's just say such a long-distance relationship wouldn't work. Typically, this is how the story goes with ants. When a young queen makes her exit from a colony to set up her own, she mates in the air with a winged male nearby. She then stores the sperm from that single aerial romance in a specialized organ aptly called the spermatheca, and then she'll use that for the rest of her life. But how she uses it is absolutely key to the survival of the colony. Quote, inside her nest, she fertilizes some of her eggs, but not all, as she lays them. The queen's control over fertilization helps her create the various castes of the colony. Sterile female workers, which hatch from fertilized eggs, build and maintain the nest. Fertilized eggs can also develop into future queens under particular conditions, such as when they are fed extra protein as larvae. Males develop from unfertilized eggs. They grow wings and leave the colony to mate with virgin queens. End quote from Science magazine. Well, this typical story, and nearly everything I just said, could be thrown out the goddamn window. Iberian harvester queens just said, hold my rosé. To figure out how the fuck these hybrids could have been made, Jonathan and the gang started with Iberian colonies, extracting what males they could find, and let me tell you, this was a labor of love. Colonies can have up to 10,000 residents, y'all. And on top of this, males may or may not show up for a short period of time during the breeding season. It all depends on the queen, and if she laid eggs and decided not to fertilize them. As reported by Tim Vernemum of New Scientist, to get around these constraints, Jonathan brought dozens of M. ubiquitous colonies into his lab. Quote, it was very difficult because in lab conditions it's nearly impossible to have males, he said. We had something like 50 colonies from along the farm roads near Lyon, France, and monitored them for 2 years without a single male being born. Then we got lucky. End quote. My friends, that's the understatement of the year. After collecting 132 males from 26 M. ubiquitous colonies, the team saw this. Please, drop whatever six-legged creature you're holding right now and pick up your phone, swipe past all those god-awful thumbnails, and you'll see 2 male ants side by side. I'll give you a sec. Yeah, that winged male on the left, that's a fuzzy M. ubiquitous. And the one on the right, he ain't fuzzy. In fact, he looks a hell of a lot like another species, a little something called M. structor. Again, this happened in a lab, in a closed environment. The researchers thought the seemingly impossible. Are M. ubiquitous queens cloning M. structor males? How? And fucking why? The first step was to confirm if those M. structor-looking dudes were actually M. structor, and I'll give you a second to guess what the DNA results were. Yep, you're right. And it's more insane than that. Genetically, these males were nearly 100% structor, with only a smidge of ubiquitous, the mitochondrial DNA matching the queen, which is basically an IP address confirming they came from her. So here's what's happening, and here's fucking why. When the queen damn well wants to, she allows M. structor sperm to enter her eggs. But, and I'm gonna try not to scream out of amazement here, at some point she removes her own genes from the egg's nucleus to prevent fertilization. So what does this do? This means that the larva will be male, and it also means he's a clone, a genetic copy. Turns out, the M. structor males that have been mating with M. ubiquitous queens have been the same clone for countless generations. As to why, you guessed it, it gets wilder. Whenever M. ubiquitous queens mate with M. ubiquitous males, whom she could also produce, by the way, all of their offspring become queens, every single one, which is a problem when you need workers for the colony's survival. So it's a bizarre quirk that leads to devastation. To bypass this issue, she mates with an M. ubiquitous male, stores the sperm to pop out a queen every now and then for the species' survival, and then clones M. structure males to mate with, to produce sterile worker females for the survival of the individual hive. It's a lot. It's a lot. And Sarah Helms-Cahan, an evolutionary ecologist at the University of Vermont who was not involved in the study, said it best to Science magazine, quote, "The end result is fantastical, but incredibly successful, with one species carrying another in its pocket, as it were, all over southern Europe," end quote. Yeah, it's a peculiar dynamic for sure. M. ubiquitous queens need their clones. Otherwise, they can't have workers. And the clones wouldn't exist without the queens and the support of the worker ants. Not only are the M. structure clones far outside the range of their species, even if they did, for example, just hypothetically stumble upon an M. structure nest, it turns out the reunion wouldn't work out. And that's just as M. ubiquitous queens planned. For you see, during Jonathan's experiment, the researchers put these clones into an ordinary M. structure colony, and it didn't go well for them. They were immediately perceived as invaders and killed. The leading theory as to why is pheromones. The clones' pheromones appear to have the chemical makeup of M. ubiquitous, and something like that would send a flare through an M. structure colony. So here we are. We live in a world where one species can produce two, if the circumstances call for it. So y'all, hear me out. I think there may be more than two genders. And thank you for listening, rating, subscribing, telling your friends. Telling your friends. Actually, you know what? Don't tell them. Show them that photo of the kangaroo rat. Just don't even bring it up before. Don't even give them a warning. Just like, hey, I want to show you something. And then, the thumb. The thumb is just too much. And then tell them that there's a queen out there that can produce completely two different species when she needs to get it on. And a sexy thanks to the folks over at Airwave Media, the podcast network to which WTI belongs. If you love this show, and you do, you love the other podcasts in this family. And please, stay interesting.